I'm just warning you. Go ahead.
Word problems. The big thing with our word problems is going to be making sure that you read it properly to get the right information out of it, right? It's also going to be that you have to kind of sketch drawings or be able to picture drawings, which I'm brutal at sketching. So I will try to show you like the best tricks I got for sketching so that it can maybe help you draw it. This first question says the dimensions of Mr. Kennedy's closet is 10 meters by 5 meters with a height of 3 meters. What is the square footage of the walls? What is the square footage of the walls in the closet if he has a door that measures 1.5 meters by 2.5 meters? So, drawing this. For me, I'm understanding it's a room, so it's going to be a cube, right? Or a rectangular prism. The way that I draw rectangular prisms is I'm going to draw a rectangle. And I'm not worried about like how it looks.
It's a square.
Okay, a square is fine. And then I'm going to do legs that go up out of it. And I'm going to go at the same measurement, so it's like that. And then I'm going to connect the tops to become my top rectangle. So that's one way to do it. Like you draw a square or rectangle, draw the legs up, and then draw another rectangle across the top. I've also seen people where they'll draw a rectangle like that.
What's a 3D rectangle? What is that called?
A prism. Draw another one underneath, and then connect the corners. Like that. Okay, so as someone who's brutal at drawing, like honestly, I'm the worst that you'll probably have as math teacher drawing. These little tricks sometimes get me out of trouble. I'm not worried about scale, right? I understand that it's supposed to be a 10 by 5, so it should be double one way, half one way. I don't care. As long as I understand I have the right shape. And then I'm going to label my shape to make it easier for me. So this is a room, which I've drawn right there. And it says in my closet it's 10 meters by 5 meters with a height of 3 meters. So I'm going to put that on my drawing. 10 meters by 5 meters with a height of 3 meters. And I know it's not the scale, but that's fine. As long as the information is there, that's what matters. So the dimensions of Mr. Kennedy's closet is 10 by 5 with a height of 3. What is the square footage of the walls in the closet if it has a door that measures 1.5 by 2.5? Let's not worry about the door for now. And let's try to answer the question, what's the square footage of the walls? So if this is the closet, the walls would be these outsides. Right? This front right here, and this side right here, and then obviously the back and the left. So we're going to calculate this the same way we've calculated all of them. I'm going to do the front first.
360. That's my quick math.
Oh, impressive. So my front would be 10 times 3. 10 and then up 3. So my front wall would total 30. My back wall would be the exact same. All right, so if my front wall is here, my back wall is going to be the exact same measurement. Then I have the right side of my wall. The right side would be 5 times 3 for a total of 15. The left side is going to be the same. It's also going to equal 15. That'll give me the walls. So if I wanted to total that up, it would be 30 plus 30 plus 15 plus 15 for a total of 90 meters squared.
I was wrong.
You weren't far off, though. You probably did the top and the bottom too.
Isn't the top and the bottom 5 times 10?
Yeah, but we didn't need to do them because it asked for the walls, right? It didn't ask for the floor or the roof.
Oh, I was doing the whole surface.
Yeah. Okay, now it did give us a door, right? And the reason it gave us a door is because we wouldn't count a door as part of the wall. So, for instance, we wanted to paint the walls or something, right? I'm not painting the door. If I'm wallpapering the walls, I'm not wallpapering the door, at least not normally. So what we need to do is we need to take that total and we need to subtract away whatever the door is. So we need to do another calculation for the door. Yeah, and it tells you the door measures 1.5 by 2.5. So 1.5 times 2.5 gives me a total of 3.25, I think. Did somebody calculate that? Get it right? Oh, after you do the subtraction? Okay, sweet. Oh, it's 8.75, not 25. Perfect. Now you can take your walls and subtract away that hole in the wall for the door to get your new total and your final answer of 86.25. That would be the surface area of the walls, right? Whenever you have a question that's about building houses or walls or something like that, be careful if they mention doors or windows. Yeah, that's kind of my warning to you because you're going to want to subtract away that total. Subtract away your doors, subtract away your windows. In this case, it was a door. Now, like I've said, like area is one of the most applicable things that you're going to have moving forward in life. So I try my best to make some of these questions relevant. So part B of this question says, if Kennedy wants to put wallpaper on the walls and one roll covers 40 meters squared, how many rolls does he need? So if one roll is 40 meters, how many rolls would it take to cover the walls?
I'm guessing it would be up to the exact square foot or the exact square meter or.
Yeah, try it. What'd you get when you do that? Because it's going to be like a good discussion point.
Well, for general, I just said there'd be 3 rolls. 3 rolls would probably be needed, but then you probably don't need the actual full 3 though.
Yeah, so you're like spot on. So to figure this out, you're going to take whatever your total is, which is 86.25, and you're going to divide it by 40. And what you're going to get is you're going to get 2.15625. And I don't normally write all those out. You don't need to.
This is all.
Yeah. Okay, and what Matthew said, because that tells you how many rolls you need. Matthew says you buy 3 rolls. He said 2 rolls, right? And he's right because 2 rolls wouldn't be enough. So if you wanted to wallpaper your walls, you would need 2.15625 rolls. But you can't buy 0.15625 a roll. So you round this number up to be a total of 3 rolls. Even though you're going to have extra now, you needed that extra to be able to cover the entire thing. So it takes 3 rolls of wallpaper to do that. That's hard, right? And we're going to do that with anything. So if we need paint or something like that, you have to have enough paint to cover the entire room. So if you have to buy extra, that's just the way it is. Right? I just wallpapered the inside of an old motorhome, and when we were putting it in, I was like, I don't know, 1 strip away from being done. And so I had to go buy a whole other roll of wallpaper just so I didn't have 1 strip in the middle of the motorhome that wasn't done. It sucks, but it is what it is. You got to buy that whole extra roll to make it happen. For sure. So then, if you're thinking about this and like say you're doing a project, now you go to buy the rolls and it says a roll of wallpaper costs $25. How much money would you need to complete the job? So I'm looking for an amount of money here.
$75.
Bingo. How'd you get it?
Well, it was really, really confusing at first. So just times it. We need 3 rolls. So just times 25 by 3.
You got it.
Oh.
So you take your $25 and you multiply it by the 3 rolls that you need.
It just took Gaten a little bit more time. A little bit.
But he got it. He got there.
Jay Sizzle got it. Man, you got it.
Gives you a total of $75 what you need. So if you're like,
the other ones.
so if you're like hiring somebody, right, to come do something like this, like do wallpaper in your house, that's how they're coming up with their estimate on how much the material is going to cost. And they're going to charge you extra too, right? They always do. Yeah, they got to make money too. If you want to do projects on your own, so you're sitting there like, I want to paint my car, I want to do this, I want to do that. Like if there's something you want to do, this is how you break it down. You find the square footage, you find out how much you're going to need, then you multiply it by the cost, gives you an idea of how much it's going to cost to do something.
What about a misshapen object, like a car?
Yeah, a car is going to be trickier. I just saw like a funny car thing where they took scratch lotto tickets and they covered their friend's entire car like with the scratch lotto tickets as a prank. It was pretty funny. So he got like 200 scratch lotto tickets, but he had to take everyone off of his car. They're all taped on. But to do a weird shape like that.
Say if you're wrapping a car, you're going to have like a little bit extra, and then you have to form it out because it comes out in like a vinyl printer or something. But
like a big roll of it too.
You're going to need extra more than not because you're going to need if you're thinking
yeah, and like a car I would break down into all of its like little parts. So like the door is a rectangle for the most part. So then you can do a rough estimation of that rectangle. The roof is going to be a rectangle. You got those little like, I don't know, the joint between the roof and the trunk and the roof and the hood. So you'd have to figure out the surface area of that little rectangle.
The car can be up to like 7 or 8 feet long. So it could only be.
A car would be hard. Yeah. All right. Birthday cake. Mr. Kennedy's daughter wants a birthday cake, like the one below. Yeah, she turns 6 on October 1st. She's gonna be big. Yeah. So Mr. Kennedy's daughter wants a birthday cake like the one below, with a top layer having a diameter of 8 inches. How much icing will he need to cover the cake? No, she wants a unicorn cake. Actually, she doesn't want cake. She doesn't like cake, but she wants a unicorn cake just because she wants unicorn everything. Yeah, just for the sake of unicorn cake, but she won't eat it.
A unicorn cake.
Craziness.
Or
I know she'll eat half. She'll eat ice cream. Right?
Or you and your partner get a unicorn costume.
That's a good idea.
And then visit her as a unicorn.
Maybe you get a unicorn
I will
costume.
gladly do that.
October 3rd, you're booked. Okay. With a cake. If you think about icing a cake. Arla, thank you. So if we are icing a cake, you have to think about what surfaces you'd actually put icing on.
Don't need to do the bottom.
Don't need to do the bottom, and you don't need to do the bottom of that circle, right? You would just put that cake right on top of the other cake, and then you're only icing the outside surfaces that you can see, like around here and in here.
Would you do the bottom? You ice the bottom?
You wouldn't ice the bottom, right? So you ice the bottom of a cake, and then the cake slides.
You have to like stick it on.
Yeah, see?
I still lose fire.
It's like stick like the circle on there so that you guys put icing on the bottom of the circle.
The point is you
Yeah.
don't not.
You don't ice the bottom.
I was just gonna say, would you just get a circumference of the circle around or no?
Which part?
Or no, never mind. I was actually asking you a question.
Okay. Okay.
I forgot we're looking for the surface.
Yes. Surface area of everything.
If I go to the washroom and go talk to this bell.
Sure.
What's the radius?
Okay, so, gentlemen,
Oh yeah, 4 inches.
all right. So we go to ice this cake. We're going to break this down into all of its parts, just like any regular question. The first side that we're going to put icing on is the front. And we know that the front is the same shape as the back. So if you want, you can just double it to get that backside, right? The front makes a rectangle. It's going to be 20 feet by 5 feet. So 20 times 5 gives us, inches, sorry.
That's a big cake.
That'd be a big cake. So 20 times 5 is 100 inches. Yeah. And the back is also going to be 100 inches. The next side that I'm going to do is the right side, right here. The right side's a rectangle. It's 10 by 5, giving me a total of 50. The left side, which we can't see, we understand would be the same. It would be 50. Now, the top. We have a trick to be able to do this top. So if you're looking straight down on that cake, this part right here plus this top right here would make a perfect rectangle that covers the whole top. So you don't need to, like I did yesterday, so you don't need to do it separately. You don't need to calculate this circle and then calculate the remainder on the outside. Instead, you got to realize that if you took that down, this top and this part would create a rectangle.
So do you do the circle at all?
You don't do the top of the circle at all, because we're going to be able to just do that rectangle on the top, which would be 20 by 10 for a total of 200.
You just got to do that label.
Right. Now, the last spot is the label. Or this outside part of the cake right here I'm doing in blue. On your formula sheet, that comes from your cylinder, right? That label part. To be able to do that part, which I'm going to call the label still, even though we know it's not a label, you need to do circumference times height. You get you? All right, thanks, Liz. All right. Circumference times height. Does anyone remember the formula for our circumference?
Pi r squared.
Close. That's area of a circle. It does have pi and r in it.
2 pi r squared.
2 pi r is your circumference. And then times that by height. Now, if you look at your picture, it doesn't tell you the radius. But if you go back to the words, anytime it gives you important information, it says diameter of 8 inches, I would make sure I write that somewhere. So for me, I'm going to point right there, and I'm going to tell myself the diameter equals 8. That means the radius equals 4. Anytime you read important info like that in a question, put it somewhere. Take that moment to actually write it out. This means that our label is 2 pi times 4 times a height of 5. If you throw that in your calculator, you get 125.663. ...
Where's your recycling?
Just outside the door. Again, your last step is to total everything up. $100 plus $100 plus $50 plus $50. I'm going to need that number from you in a second there, Jordan, because you're right. What'd you get? 500?
500.
I want to put 0.7. So our final answer is 525.7, and that would be inches squared. Although it does look like I put feet, and you don't want feet. We're going to say those are inches. If that was feet, that'd be sweet cake.
Why does it say feet?
So 1 tick is foot, 2 ticks is inches. So I only put one tick. That's my bad.
Man, these word problems.
The word problems are hard. Yeah, and it's only like if you can figure out what you're needing to put your surface area on, like that's the big trick usually, right? Our next question. After winning a selfie competition, Mr. Kennedy won a trophy shaped like the image below. The trophy is gold-plated, meaning that there's a layer of gold around the trophy, but it isn't solid gold all the way through. How much gold plate is on the trophy? I actually did win a selfie competition once. No big deal. Won that bobblehead. Pretty sweet. I don't know, a pyramid trophy. I've seen trophies like that. They look cool.
So this morning I talked to Garo about the teacher procedure fight, and
Yeah.
he said he was down.
I know. See, Miss Lammer wasn't. She said no. but I think we can get this built up. We gotta get this hyped up.
I said him versus Mr. Payne.
Let's make
like that'd be a good fight.
Then we gotta go on the announcements and like announce it.
We gotta talk to
Okay, so go ahead. Man.
Yeah, so it's not skip one.
I skipped one.
Yeah, I think so.
Yeah,
Should we not put a bubble?
Did I skip an example?
They were number
Mr.
4.
Kennedy is using old Pringles.
Oh,
Aha.
I like my trophy question more. Mr. K is using an old Pringles can as decoration for Easter. His plan is to paint the can, which is 30 centimeters long and 8 centimeters wide. How much paint will he need? Okay, drawing a cylinder.
Then 2 circles and 2 lines.
Yeah, like I suck at drawing. So do a circle, do another circle, and then connect the outsides.
Cylinderish, I think you're good.
Honestly, that's as good as cylinder you're ever going to get out of me.
You should connect the top of the circle to the bottom of the circle. Might look better.
Very
But
cool.
who knows? I'm not
Like that? Oh, that is okay.
No. See, top to bottom. Because then it doesn't look like a weird circle on the top. Yeah. No.
You're just a better artist than me, Jane.
No. You guys are good.
All right.
No, it's not. That is not similar.
I don't know.
So when you're doing these questions, important strategy, draw the picture of what you want. I wanted a Pringles can. Pringles can's a cylinder. Second important part, label it. So find out the info from that question. Highlighting goes a long way. It said his plan is to paint the can, which is 30 centimeters long. So 30 centimeters long and 8 centimeters wide. When they told me it was 8 centimeters wide, that's this distance in here. That would be the diameter.
So you gotta divide the 8.
Right? Like if you were measuring the width of a can, you would go on the top of the can and measure the width of it. You wouldn't go from like the side and wrap it around or something crazy like that.
You gotta divide the 8 by 2.
Yeah. So if we want to use radius, that means we divide it by 2.
So it says it's in 2.
Yeah. All right. Reese. Up here, man. Thank you. Do this in chunks. If you want to do the circles first, that's fine. So the circles. I'll do the top circle first. The area of a circle is pi r squared. R is radius. Our radius in this case is 4 because I had to divide the diameter by 2. That means the area of my circle is pi times 4 squared. In this case, it's 50.265.
When we do all the formulas gonna be on the first, or should we say our formula is like
You just get your formula sheet.
Wouldn't it be easier just to do it all in one part?
What do you mean?
So if you just went pi times r times like,
Yeah, I mean, it might be easier if that's how you want to do it.
it just seems fast.
I was just doing the area of the circles. So far, all I've painted is the top and the bottom circle. And I know the bottom circle is the exact same, so that's why I wrote it out. I haven't done the label yet. And you might do label faster, like what you just said. That might be easier.
Yeah, I did it all in one.
Yeah, that's fine. The next section I'm going to do is my label. We know that the label is circumference times height, which is this right here. Our label is 2 pi r, that gives you my circumference, times the height of 30, which in this case, you go 2 times pi times 4 times 30, you get 753.982.
That's all close to even.
It'll come back.
I was just gonna ask, even if you take out the cylinder and make it into a 2D object, say if you roll it out,
Yep.
and so it'd just be the circle on the end and no circle and a rectangle.
Yes.
Would you be able to solve the problem with that?
That's exactly what you're doing. So if it looked like this, so when you unfold one of these things, you get like a circle, rectangle,
Yeah, no, just like that.
circle. Yep. And then when you're doing that rectangle part, the label is what I always call it. It's the height of the can, which is right here,
No, yeah, exactly.
and then this width is the
So
circumference.
it's the whole cylinder, yeah.
Yeah, you got it.
What's the final answer?
Really?
Your final answer is going to be totaling that up.
800
I'm going to need that again in a second.
Terrified.
What'd you get? 800 and...
Nah, I was making my best guess. Please don't say it.
854.5.
I was close.
With these word problems, Braden, with these word problems, there's going to be a lot of info on your page. So please make sure that you're boxing your answer so that I know what answer you have. Okay, try to keep it as organized as you can. So try to work vertical, the best of your ability, and then square up your answer so I know where it is. Yes, sir.
For that gold plated one, when you do the full surface area, is that just the surface area at the top? Don't question, never mind. Just kidding.
Yeah, you're going to go all the way around. So it's going to be all the sides and the bottom.
Can you go back up?
Yeah.
You're welcome. So, example 4. After winning a selfie competition, Mr. Kenny won a trophy shaped like the image below. The trophy is gold plated. When you buy things, especially jewelry, a lot of the things you see are going to be plated. They're not actually gold, not actually silver. It's always like a plating that's around some other metal. That's what they're doing. They're taking another metal and then they're just sticking like a gold surface on it, so it looks gold. It's plated. It makes it a lot cheaper. Yeah, to make it a little bit more solid, right? Because it's actually really soft. You can scratch it off and stuff. Yeah, that's why they don't make it completely out of something.
You do an electric bath. It's all liquid gold, like chemically liquid. It's like an acid.
That's cool. And they actually do the same thing with wood too sometimes. So they'll take a different type of wood, like a cheap wood, and then they'll plate it. So they'll put it's called I think they call it a vinyl finish. What do they call that? Veneer. They put like a veneer around it, but it's plating it, so it looks nicer. But you actually have cheap wood underneath. Here we go. Yes, sir.
It's kind of like that tree of plywood.
Yeah, it's the same trick, right? They take a cheap wood, put something nice on top of it so it looks nice. So that's what they did with this trophy. They gold plated it. It says how much gold plating is on the trophy. To figure out how much it took to cover that trophy, they're asking you the surface area. How much gold plating? That's surface area.
What?
Surface area is how much it takes to cover something.
can just get a 5. You divide by 5, and then you divide it by 2. And then you gotta times it by 4.
70 inches of full
So if you're looking at this and you want to break it down, you're going to break it down the way Braden just said. So you're going to do one side first. I've got this triangle on the outside. I'm going to try to figure out the area of that triangle. I'm going to call that the front. Area of a triangle is base times height divided by 2. In this case, the base is 5, the height is 4.5, and then you divide it by 2.
times it by
5 times 4.5 divided by 2, you get 11.25. We also know, looking at this triangle, that it's the exact same triangle on all 4 sides, right? This one is also 5 by 4.5. That means the back is also 5 by 4.5.
They should make
The side is also 5 by 4.5. Sometimes it's not all the same. So you need to look carefully and check to actually make sure all the numbers are the same all the way around. Sometimes they switch. And then it's not the same and you can't just multiply it by 4.
The triangle cannot be square.
Yeah, if the bottom's a rectangle, then it's different. For us, it's all the same. So that means my back is also 11.25. The left side is 11.25. The right side is 11.25.
Is this entire store we got Wi-Fi connection or is it just your room?
My room.
just this room.
Pretty much just me. I'm like in some sort of box of.
I mean, Joe Anderson had some of that Wi-Fi in grade 9.
Yeah. I think they fixed yours. Yes, yours. Yep. The last side that you have to cover is trophies all the way around. So that means they would have plated the bottom. If you're looking at the bottom is this square under here, which would be 5 times 5 is 25. Your last step, just like we've done with everything else, total all up. So just add all your things together. 11.25 plus 11.25 plus 11.25 plus 11.25 plus 25. It should equal 2, 3, 4, 4, 45, 70. It'd be 70 inches squared.
It's actually 69.95.
69.95? Maybe double check. I think you might have hit a 1 instead of a 2 when you're doing your 11.25s. One of them might have been 11.15. Because then you'd be just short. Yeah, it's bad internet. So it goes fuzzy.
Wrapped up.
All right, the next question says, if it costs $20 per square inch to plate the trophy, how much did it cost to put the gold on? Yeah, Jordan. How'd you get that?
70 times.
Yeah, so if it's $20 per square inch, per means for every. That means every one of these square inches costs $20. So if you want to figure out what the whole thing costs, you're going to go $20 and you're gonna multiply it by the 70 square inches you have to get, was it 1,400? $1,400 trophy. And that's just for the plating around it.
But wouldn't it just kind of like wood or something underneath that?
Yeah, there'd still be more cost to it, just for the inside part.
Oh, it's like keep it sturdy.
Yeah, make it cheaper. Example 5. After winning a selfie competition, Mr. Kennedy treated himself to a mini ice cream. What is the surface area of the cone and the ice cream? The top part of the ice cream, the pink part on my page, would be half of a ball, right? We can imagine that that's a whole scoop in there, but the top part is only half of that ball. So what you want to do is you want to use your half of a ball formula. You're going to do the whole ball and then divide it by 2. On your formula sheet, remember that you do have formula sheets in this class. Looks like this.
4 pi r squared?
Your ball formula is on the 3rd page. Right at the bottom, it's called a sphere. The formula is 4 pi r squared. And we only want half of that, so once we get our answer, we're just going to divide it by 2. So if I'm doing just the top part, it's going to be 4 times pi times 1 squared. Put that in your calculator. And you get 12.566. But you only want half of that because you can only see half of that ball of ice cream. So you're going to divide that answer by 2. What'd you get there, Matthew? 6.2?
6.28.
Thank you. 6.28. Perfect. The next part is the cone part. We called this section, so the actual cone part, we're calling it the incline or the cone. When you look at your formula sheet for a cone, it tells you how to do the whole thing. So that tells you how to do the circle on the top and the cone part. You need to not do the circle part. So when you're looking at your formula for a cone, it tells you the surface area is pi r squared plus pi rs. The pi rs is the part you want. The pi r squared is the circle on top. Yeah, Laura. One of these? Okay, I'll get you one. Okay, I'll hand you one after. Okay, I'll hand one to anyone who doesn't got one. So you're looking for the pi rs, where S is the slant height of that cone. You do not want to do the other part of that formula. The other part's the circle. If we put pi rs into our calculator, so pi times r, which is 1, times s, which is 5, you get 15.707 dot dot dot.
Pi's are 1 pi. When r is equal to that, you didn't need to put r.
You can get away without multiplying it.
I totally forgot to put r in it though.
Yeah. Because multiplying by 1 is just doing itself, so it's fine. You now have the cone and the ice cream. You can add up to get your total. It's 6.28 plus 15.707. And you should get 21.98, which would round to be 22. And that's inches squared, yes. Yeah, Jason. Yes, sir.
A lot of work on to get to these.
Right? Okay, the last one I want you to just try on your own. How well can you read those numbers? Lunch. But we got to get through the question first. Gentlemen, Arla, once we get through this question, you'll be dismissed. Thank you. When you do start looking at floor plans, this is how they'll kind of be broken down. So that's an actual floor plan of an actual condo. They'll write in like an area for each one. It's hard to read it, so I'm having a hard time reading on my screen. But you're just going to break down every single area. So we'll do kitchen first. The kitchen would be 5.3 times 2.8. You put that in your calculator. Thank you. Is that Miles? Thank you, Miles. The next one we're going to do is our living room. Our living is 5.5 times 4. It's frustrating. It's 22. Yeah, the worst the internet gets, like lagger gets, and it connects my letters. So like if you look at the word living room, like it connected the V and the I because it's so far behind. Then I got, let's do a bathroom. Is that a 1.6
Yeah.
by 2.7? 4.32. We got a hallway. 3.6 times 2.4. 8.64. And we got a bedroom. 3.6 times 2.7. For 9.72. If you total it all up, would you get Miles? 50.
9.52.
Thank you. And that's meters squared, actually. Typically, when you do this, they'll give you square feet. So if you do actually go look at house plans, it'll be measured in feet, and they'll give you the square footage. This would be the square meters of a place.
Wait, so that'd be a pretty big apartment.
It would be a pretty big apartment, yeah. And if we,
Yeah, you have dogs.
so
Letting it grow, fattening it up.
we're gonna rough estimate it to be 635 square feet.
Small place, Mr. Kennedy.
That is actually pretty small.
Okay, so that's actually your house?
No.
So that's the rest of your daughter?
There's no rooms for any of the family.
No, it's just that big. A lot of heel crack. Where is it?
Okay, part B. Says in the kitchen, Mr. Kennedy wants to use a fancy tile that costs $120 per square foot. How much would it cost to put flooring into his kitchen? To figure that out, you're going to have to figure out the square footage of the kitchen. It was 14.84. We're going to roughly estimate that to be, we got to do square feet because that was square meters, right? So that's my bad on having meters and then square feet. It's going to be roughly like 150 square feet.
That's a good kitchen.
$76.
So if it's 120 per square foot, you want to do 120 times 150. And that will tell you how much the flooring will cost.
18.
The 18,000 for that tile. Now, when we were building our house and we did the flooring, you could pick like the basic cost, which is nice and cheap, but they have some flooring that does cost crazy amounts like that. And it'll like quadruple the cost of your building just by putting in different floors. It's kind of wild. So this would cost $18,000.
You're not going to get another $18,000 for the.
Right?
You're only going to get like an extra like maybe like 5 or 6 grand.
Yeah.
So would it really be worth it?
It's only if you want to look good, I guess. To me, it wasn't worth it. We did cheap floor.
Yeah, so it's final.
Yeah, that's what we did. Yeah, nice and cheap.
It'd be cheaper to like buy it yourself. Like you can like pay higher and just buy those like things like wood. Just
Okay.
those planks or whatever. Yeah. Really hot wood.
It'd be cheaper just to buy
So next
it
part-
and then just down to the size that you want and place it in after.
The next part says, after realizing his furniture wouldn't fit, we're going to be here all the way to 11:30 today. We're leaving when this question's done. If this question's done in the next minute, we're leaving. If it's done in the next 6 minutes, we're staying that long. It says, after realizing his furniture wouldn't fit in his new bedroom, he decided to extend the room to double both the length and the width. So if you double your length and your width, how does it change the square footage? So you could actually do the calculations to figure it out. But there's a quicker way to do it. So if you double your width, say you double just one thing, then that would double your area. If you double the width and double the length, then you're doubling both sides. So you could take your surface area and times it by 2 twice. So by doubling the width and doubling the length, you're doubling your surface area 2 times. Also just timesing it by 4. You could write that out, so it would
38.88.
it would double his area or his square footage. So square footage is SQFT. It would double his square foot 2 times or twice.
Maybe 4 times.
But I said doubled it 2 times.
Maybe 38.88.
Yeah.
That's big. You're rounding 38.
The last question, Mr. Kenny has a round table with a diameter of 2.5 meters. How much space will his table take up in his kitchen? In your opinion, is that too big of a table? So it told me that the table was 2.5 meters diameter. So to figure out if something's too big, you need to figure out the area of the table and compare it to the area of the room. The area of the table is going to be pi r squared, which in this case would be r is 1.25, right? Because they gave me diameter, so I did divide it by 2 to get the radius. When you do that, 1.25 squared times pi, that is 4.9 ... meters squared. If you compare that to the size of the kitchen, so I have 4.9 meters squared for my table, my kitchen is 14 meters squared up here. Do we think that your kitchen being 14 and your table being 4.9, is that reasonable, or do we think that's too big, too small?
That's like almost 1/3.
It's 1/3. So like 1/3 of your kitchen would be your table space.
This is family. Like,
That's a lot.
That's pretty big. Like
Decent sized table.
you've taken up a lot of room. So honestly, it's kind of borderline. So you can say it's okay as long as you say I'm okay with having a big table in my kitchen. You could say it's too big if you feel like you want more room for other things. So it is up to your interpretation, but you need to reference the size of both things. So you could say 4.9 meters squared is fine for a kitchen that's 15. Or you could say 4.9 is too big for a kitchen that's 15. No wrong answer as long as you reference both numbers. So you talk about it.
Should a decent size.
what is that?
Yeah.
It's like